Hello and welcome back to Code with Vinay. Today we are diving into a curious Java phenomena known as the autoboxing trap. A wrapper class in Java is a class that encapsulates a primitive data type, turning it into an object. For example, the integer class over here wraps the int primitive data type. Autoboxing in Java is the automatic conversion that the Java compiler makes between the primitive data types and their corresponding object wrapper classes. For example, converting an int to an integer, a double to a double with a capital D, and so on. This feature was introduced in Java 5 to make it easier to write code. Let us understand this with the help of an example. Notice line number 3. Here we are saying integer, which is a wrapper class, and then we are having an object of integer, and that is followed by equal to 100. This a is equal to 100 is actually autoboxing. The primitive value 100 is being directly assigned to an object. The object-oriented version of the same thing goes like this. We say integer a is equal to integer dot value of, let's say, 200. So, when you assign a primitive value to an object of its corresponding wrapper class, the compiler automatically converts the primitive value to an object, and this is autoboxing. So let us now move on to the actual thing. What is an autoboxing trap? So if you look carefully, you will find that we are storing 100 in object A. We are trying to store 100 in object B. Then we are comparing the two objects. Then we are storing 1000 in the object C and again 1000 in object D. And then we are comparing C and D. Now if I run this code, you'll notice something peculiar. Let me run the code for you. The first print is outputting true, whereas the second print is displaying false. Why does this happen? Let us find out. Remember, when using equals with objects in Java, it compares their memory locations and not their content. So, equals check if two object references points to the exact same object in memory rather than checking if the objects have the same value. This peculiar behavior is due to how Java handles integer objects and a concept called caching. Java does a bit of magic in the background with integer values between -128 and +127. When we assign an integer value within this range to an integer object, Java uses the same object from a cache of integer objects. Let me explain this with the help of a diagram. So, when the computer reaches line number 3, that is integer a is equal to 100, computer allocates memory for the object and the value 100 is stored inside it. Then we have a reference variable by the name of a, which references this object. When computer reaches line number 4, where we are saying integer b is equal to 100, notice this value 100 is between -128 to +127. So these will use the cached values. That is, now instead of creating another object with the value 100, the reference variable b is now going to point to the same object in memory. So when you say at line number 5, a equals b, computer checks whether or not a and b are pointing to the exact same object. A and B are pointing to the exact same object, hence this is going to give true. That is this. Now let us see what happens in the second half of the program. Now here we are saying integer C is equal to 1000. So an object is created with the value 1000. Then a reference variable C refers to that object. And then we go to line number 8. Now this value 1000 is not lying between this range. So what happens is that now computer creates another object. The value stored is again 1000 and the reference variable D refers to the same object. But now when you say C equals D, computer will compare whether or not these reference variables C and D points to the same object. They do not point to the same object, though they contain the same value. So this becomes false. And that's why we are getting a false over here. Now here's a twist. You can actually modify this caching behavior using a compiler switch. Let us see how it works. So I'll compile the program again, but this time I'm going to do it manually via the command line. So I'll say Java C. Java C means Java compiler. That will be followed by the name of the file. So if I press enter, the program is compiled. And now while running the program, I'll give the compiler switch. I'll say Java minus XX colon auto box cache, and then I'll say max, and then let's say I say 2000, and that will be followed by name of the program, which is again Autoboxing trap. So if I run the program now, you can see we are getting true in both the cases. We have modified the maximum value from plus 127 to 2000. Also note that while there is a compiler switch to change the maximum cache value, there is no compiler switch to change the minimum cache value. The minimum cache value, that is minus 128, is fixed. The upper cache value is by default 127. You can change it to any other higher value, but you cannot change it to a value lower than 127. Remember, while this is a neat trick, it's not commonly used in everyday programming. It's more of an interesting aspect of Java's inner workings. Always use dot equals for comparing integer values, not equals to avoid into this autoboxing trap. That is, it's better to say A dot equals B instead of saying A equals B. And similarly, instead of C equals D, it is better to say C dot equals C. While you might not use this concept in everyday programming, it's important to understand it, especially for tackling MCQ questions in exams or interviews where such nuances are often tested. And that's a wrap on today's Java journey. I hope you found this exploration into the world of autoboxing as interesting as I did. See you in the next video. Till then, happy coding. Your feedback is valuable to me. I want to make sure that my videos are clear and helpful. You can follow me on the internet on any one or all of these channels.